Greetings and welcome, friends. Mr. Waddy here. We are taking a look at last night's quest on section 3.5. This is actually the last day we spent on graphing linear equations using slope-intercept form. And yeah, good time. So here's question 32, just because it's great to practice. Now this, I would point out, is not in slope-intercept form. Slope-intercept form is y equals mx plus b, in which the m represents the slope of the line, the steepness of the line, and b represents the y-intercept of the line. And so notice this is not in that form. To get it in this form, most frequently you just need to solve for y. So let's get y by itself. Actually, oh wow! I was going to move the 2x over here and the 6 over there. And then I'd have to multiply everything by -1 to change the sign. But you know what I realized? Let's just move the y over here. I move one thing, and it'll already be solved for y. I can do one step instead of 3. Now, you wouldn't have been wrong doing it the other way. I would have given you full credit, but I was just pointing out this is far more efficient and therefore elegant. Let's see. So y, let's see, a y equals, if I flip it around, 2x plus 6. So here's my slope-intercept form. What is the slope here? What do you guys think? Slope, friend? Nope. Slope is the m, like mountain. So it's just 2. The x isn't part of the slope. The slope is just the coefficient of the x, which means the number that's being multiplied by it, or the number in front of it. And if it helps, you could think of that as 2 over 1 if you want to think of rise over a run, but you don't have to. So there's our sloppy slope. Let's see, and what is the y-intercept here? 6, right, which that 6 kind of looks like a b. They were buddies to begin with. And so if I want to graph this, I begin with b. So let's go up to 6. 1, 2, 3, 4, 5, 6. Wow, lovely. Right there is my beginning, and my slope is 2, which means a slope of 2 over 1 for the rise over run. So go up 2 and over 1 right there. Up 2 and over 1 right there. And if I say this was going to like run right off the graph and I didn't have space to fit my point, I can think of 2 over 1 as being equal to -2 over -1. And watch this trick. I could have gone down to the -2, right? And backwards 1, that -1. And this point would be on the line just like those points were on the line. So that is a nice trick to be able to get some more points on your line. Let's see, and then I create my line because my line does have infinitely many solutions for my equation, right? Where all the points on this line represent a combination, a pair, an ordered pair of x, y that makes the original equation true. All right, it makes that equation true. It also makes this equation true, the equivalent equation. So yeah, so there you go. So get it in the slope-intercept form, find the slope, find the y-intercept, bam. Oh, it also asked us to identify the x-intercept. Where do you guys think the x-intercept is here? What's the value of the x-intercept? Where does it cross the x-axis? -3. -3. Now, because you have a quiz today and you have to know how to find the x and y intercept without a graph, I'll also do this using that method. When you find the x-intercept, you set y equal to 0. You remember that? And so I could have, even from the original equation, 2x minus 0 plus 6 equals 0. And then I'd have 2x plus 6 equals 0. And I would have solved for this. And hopefully we're going to get a -3. Oh, man, I can't write and speak at the same time, apparently.
I know how to set 0 for every.
Oh, I was plugging it in this one, which had the equal 0 there. But you're right, I could have plugged it in here and 0 for this y and then solved for that x, and that would have been just as fine. I was just trying to avoid it. And so I do get x equals -3 as my x-intercept, which also notice agrees right there. All right, so the intercepts method for graphing was different than slope-intercept form, where you would find the x-intercept by plugging in 0 for y, you'd plot that point, then you'd find the y-intercept. How did we find the y-intercept? Do you remember? I'm not going to do it. We would plug in 0 for what? 0 for x. Yeah, quite the opposite of what we would have expected.
So when you plug in y.
Yeah, so 0 for y, you get the x-intercept. 0 for x, you get the y-intercept. And if I plugged in 0 for x, I would have gotten 2 times 0 is 0, y equals 6, and notice y equals 6 is right here. So if I was to graph using the intercepts method instead of slope-intercept form, I would have plotted the x and y-intercepts and then drawn the line. All right, let's talk some of these wordier problems. It says in exercise 33, graph the function with the given description. Identify the slope, y-intercept, and x-intercept of the graph. It says a linear function f models a relationship in which the dependent variable, which variable is the dependent one? Do you remember? That's going to be the y, the output, okay? Decreases 4 units for every 2 units. The independent variable, that's x, variable increases. Okay, so for that first part, they were actually giving me a rate of change regarding decreasing and increasing. So it says the y is decreasing by 4. So the slope is going down 4 for every 2 units that x increases. Down 4 for over 2. What does that slope simplify to? What's the number that divides both into 4 and 2? 2, yeah. 2 goes into 4 twice and into 2 once. So I would get a slope of -2. Now they told me this fact, the value of the function at 0, meaning when x is 0, the independent variable is 0, okay, is -2. So they just told me 0, -2 is on the graph, which conveniently happened to also be the y-intercept. B equals -2. Okay, so let's plot these points. So here's 0, -2, like so. My slope is -2. So I'd go down 2 and over 1, down 2 and over 1. Now we are having fun. We're graphing lines all the time. Slope intercept form. All right, I don't know. I was just rolling with it, but there we go. Here we no. Let's see. I'm gonna pick a point farther away. Up 2, backwards 1. There we go. Graphing lines. And voila. There we are. Good times, good times. All right, and now for an actual problem of words. Here I chose question 36 for us to look at. It says a linear function m models the amount of milk sold by a farm per month. Milk. All right, why did they choose m though? M was my slope variable thing. The amount decreases 500 gallons for every $1 increase in price. That sounds like a rate of change. Even the phrase for every, I could have said per in there, P-E-R. That's a rate. I'm seeing slope all over that, right? So I'm going to say m, my slope, not the variable, the output m, milk. My slope is equal to, let's see, 500 gallons for every $1 increase in price. So that's decreasing 500 for every $1 increase in price. All right, so 500 gallons less for every $1 increased. All right, so there's my slope. It says graph m when m of 0 equals 3,000. Okay, m of 0 equals 3,000. Let's see, did they tell us what the input was? The increase in price. So if I increase price by 0, you're selling 3,000 gallons of milk, I believe. And m of 0 equals 3,000, so that means 0, 3,000 is one of the points on my graph. Agreed? Yeah? No? Maybe? No? Yeah? And that happens to be my y-intercept. And just to describe this, so this is the increase in price measured in dollars, all right? And this is the gallons sold, right? Amount of milk sold, yeah, gallons sold. That G looks very Y-ish. There we go. Gallons sold. So if I keep the price the same, if I increase the price by 0, that's to keep it the same, the gallons sold is 3,000. Every dollar I increase it by, I expect to sell 500 less gallons of milk, and some poor children will go without milk. Man, these milk farmers, they're in a tough situation here, but they gotta feed their own families. Whew, wow. All right. So I see 3,000 as a possible Y value or M value. I'll call this P price. Okay, M for the milk gallons sold. 3,000, I've got to have my Y-axis go at least up to 3,000, or my M-axis, if you will. And then it's going down from there, so I think that'll be okay. So let's see, maybe I count, I think I'll have enough space if I do 250 for every line. You think I'm going to fit up to 3,000 here? Do you think I gave myself enough space? I hope so. All right, there's 3,000. And my price axis, I'm assuming we're not going to increase the price by like $10 a gallon, so I'm going to just do every other is 1. Right, something like that. And, oh, it said to identify the x-intercept. Okay, I think I gave myself enough space, luckily. So let's see, so let's graph this. So 0, 3,000 is on the graph. When I keep the price the same, I'm selling 3,000 gallons of milk. And from then on, it's decreasing by 500 per $1 increase. So down 500 and over 1. Down 500 and over 1. Okay, let's draw that line. Milk, milk, milk. Milk, 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 milk. Let's see, now I could line up my point right there. Or if I just pick one further away, where it still passes through those points. Looks something like that. Here's my milk line. And so what this graph represents is kind of gives us an idea. If I increase the milk price by $3 a gallon, I'm only going to be selling 1,500 gallons of milk. If I increase the milk price by $6 a gallon, let's say I just get super greedy, am I making any money? No, I'm selling 0 gallons of milk if I increase the price to another $6, right? So as far as, yeah, bless you, as far as, you know, this now decision that these milk farmers would have, right, you'd kind of be like, man, what do I do? I don't want to increase it that much because then no one's buying milk. You know, if I increase it by this much, I'm only selling 500, but I'm selling it at $5 more per gallon, and you got to kind of figure out what you're comfortable with and who you're, you know, selling your milk to, I guess. There's potentially an ethical situation here as well. So it says identify the slope and interpret the x and y intercepts. So the slope was decreasing $500, right, or 500 gallons for every $1 you increase the price. Let's see, what's the x-intercept on this? I already pointed at it. We already kind of described it. The x-intercept was 6, right? Or the point 6 comma 0, meaning if you increase your price $6, you're selling 0 gallons of milk. Let's see, the y-intercept was 3,000, which corresponds to the point 3,000, which means that if you keep your price the same, you're selling 3,000 gallons of milk. Actually, I realized that I was wrong with this interpretation earlier. This was an increase in price. So a $6. No. You still would make $0. We don't know what they were originally charging for the milk, but yeah, if they increase by 6, they're still selling 0 gallons of it. Okay, I just wanted to make sure I wasn't all crazy on that. But what I was wrong about was that if I pick like this point, I can't just simply multiply this by that to figure out how much money we made. That's how much more money we made, so to speak, because of the increase in price, right? Increase. It wasn't the total price of the milk. All right. So thanks for watching, Internet friends. Hope you have a great day. Bye-bye.